Here are the top 10 most important things you must know about quadratics. Must know number 1. What is a quadratic relationship? Let me show you how you can recognize a quadratic relationship from the 3 ways any relationship can be represented: from an equation, from a table, and from a graph. An example of an equation that involves a quadratic relationship between an x and a y variable is y equals x squared minus 6x plus 8. This is a quadratic relationship because the highest exponent on the variable is 2. Quadratic relationships are also known as degree 2 polynomial equations. Now let me show you a table of values for this quadratic relationship, and we'll analyze the properties of that table. I'll choose some x values, and now I'll calculate y by taking each of these x values, summing them in for x into the equation, and getting the value for y. From this table, you should be able to tell that the relationship between x and y is quadratic. And how you could tell that is by analyzing the finite differences of the y values. If I look at the difference in the first pair of y values, always do the bottom one minus the top one, so 0 minus 3 is negative 3. And then do that for each pair of y values. Notice they're not constant, so it's not a linear relationship. But if I were to find the difference in each of these pairs, notice that the second column of finite differences is constant. And that's going to be true for any quadratic relationship. And now I'll plot each of these points from this table, and we'll see what the graph of a quadratic looks like. If I connect these points, I get this U-shaped graph, and that U-shape, we call it a parabola. All quadratic relationships form that parabola shape. And these parabola shapes have a couple important characteristics. All parabolas have a vertex, which is its max or min point. So I'll label it in green here. Here's the vertex of this parabola. And another important feature is all parabolas are symmetrical about a vertical line that goes through the vertex. And we call that the axis of symmetry. And now you know how you can recognize a quadratic relationship from an equation, table, and graph. The second thing you must know about quadratics is the standard form equation of a quadratic. The standard form equation of any quadratic relationship takes the format y equals ax squared plus bx plus c, where a, b, and c could be any real number. From a standard form equation, we can tell a couple properties about a quadratic. The a value will tell us the direction of opening. If a is greater than 0, I know the parabola opens up. And if a is less than 0, the parabola opens down. Another important feature of the standard form equation is the c value. The c value reveals the y-intercept of the quadratic. The y-intercept will be at 0, c. And now let me give you an example of this. Let's say we have the quadratic y equals 2x squared plus 4x minus 5. In this quadratic, the 2 is the a value, 4 is the b value, and c, the constant, is negative 5. What do these tell me about the quadratic? Well, since the a value is 2, that's bigger than 0, so this quadratic opens up, and the c value is negative 5, so I know the y-intercept is at 0, negative 5. If I wanted to see what the graph of this relationship looked like, the best way to graph it when you're given the standard form equation is just to make a table of values. You can choose your x values, and then calculate your y values. And you'll get good as you learn more about quadratics at picking good x values, which will give you the good parabola shape of the quadratic. Calculate the y's just by subbing all of your x's into this equation, and then plot them to see the graph. Now you know the standard form basics. Must know number 3, vertex form basics. There's another format that the equation of a quadratic relationship can be written in. It's called vertex form, and it looks like this: y equals a times x minus h squared plus k. The important thing to know about this format of a quadratic equation is that the h and k values tell you the coordinates of the vertex. So off to the side here, I'm just going to sketch a random parabola, and its vertex would be at hk. The axis of symmetry is always the vertical line that goes through the vertex. So the equation of the axis of symmetry is going to be x equals the x coordinate of the vertex, which is h. So the equation of the axis of symmetry is x equals h. And lastly, just like the standard form equation, the a value tells us the direction of opening. If a is greater than 0, the parabola opens up. And if a is less than 0, the parabola opens down. Now let's say we had a quadratic that was in standard form, and you were interested in the vertex of that parabola. What you could do is you could convert it to vertex form through a process called completing the square. And let me give you an example of that. Let's say we had the quadratic y equals negative 2x squared plus 20x minus 11. In order to get that into vertex form, you put the first two terms into a group, you common factor out the coefficient of the x squared from the first two terms only, and then I left spaces here for the number that we have to add and subtract to that quadratic in the brackets to turn this into a perfect square trinomial. It'll be a perfect square trinomial if the constant at the end is half of the b value squared. So half of 10 is 5, and 5 squared is 25. So I'll add and subtract 25 to keep it equivalent. Get the negative 25 out of the brackets by multiplying it by the negative 2 in front. And then factoring the quadratic that's in the brackets should be easy because it's a perfect square trinomial. The numbers that multiply to the c value and add to the b value will be the same number twice. It'd be negative 5 and negative 5, so it would factor to x minus 5 squared. And now that it's in vertex form, the h and k values tell you the vertex. Notice from the vertex form equation, h is what we're subtracting from x. So in this equation, we're subtracting 5, so the h value is 5. So the vertex is at 5, 39, and the axis of symmetry would be at x equals 5. And because the a value is negative, this parabola is going to open down, which means this vertex is at the top of the quadratic, making it a maximum point. And I can make a rough sketch of that quadratic for you. The vertex is at 539. From the standard form equation, I can tell the y-intercept is at negative 11, and I know this parabola opens down. Now you know the basics of the vertex form of a quadratic. Must know number 4, factored form basics. The last format of a quadratic equation you need to know is the factored form, and it looks like y equals a times x minus m times x minus n. Let me make a rough sketch of a random parabola, and we'll talk about what the factored form tells you about that parabola. Since the factored form is a product of factors, if we want to know the x-intercepts of a quadratic, well, we know what the x-intercepts, y is 0, so we would just figure out what makes any of these factors be 0. X minus m would be 0 if m was 0, and x minus n would be 0 if n was 0. So if x was either m or n, this whole product would be 0, meaning it's an x-intercept. So the x-intercepts are at m and n. And then, because parabolas are symmetrical about the axis of symmetry, I know that if I found the average of m and n, that would give me the axis of symmetry. So the equation of the axis of symmetry would be x equals m plus n divided by 2. And lastly, of course, the a value tells us the direction of opening of the parabola. Let me give you an example of a quadratic that's in factored form. The most useful part of factored form is it's easy to find the x-intercepts. I know at any x-intercept, the y value is 0, so I could set y to 0. And then using the zero product rule, I know the product of these three factors is 0 if any of them are 0. X plus 2 could be 0 if x was negative 2, and x minus 6 could be 0 if x was 6. So the x-intercepts are at negative 2 and 6. Let me make a rough sketch of what we have so far. Now, if I was interested in the axis of symmetry, I know it's going to be right in the middle of these x-intercepts. I can find the middle of negative 2 and 6 by adding them and dividing by 2. So the equation of the axis of symmetry would be x equals negative 2 plus 6 divided by 2, which is 2. Now, the vertex of this parabola is going to fall somewhere on this axis of symmetry. So I know its x-coordinate is going to be 2. And to calculate the y-coordinate of the vertex, we could just take this value of 2 and sub it in for both of the x's in the factored form equation. And if you do that, you would get a y-coordinate of negative 8. So the graph of this quadratic looks something like this. There you go. Now you know the factored form basics of quadratics. Must know number 5. You have to know how to factor quadratics. And we factor quadratics as a means of getting a standard form quadratic converted into factored form. And let me give you 3 examples of typical quadratics that you may need to know how to factor. Let's look at this first quadratic. When the quadratic in standard form has a leading coefficient of 1, so an a value of 1. We can do a product and sum method of factoring this quadratic where we find numbers that have a product of the c value and a sum of the b value. The pair of numbers that multiply to 24 and add to 11 are 8 and 3. So what we do with those numbers to convert the standard form quadratic into factored form, we make two factors. The first term of each of those factors is x, and then to each of those x's, I add the pair of numbers that satisfy the product and sum. So I take the 8, put it here, and I take the 3 and put it here. And there we have it. There's the equivalent factored form of this standard form quadratic. The next type of quadratic you have to know how to factor is one where the a value is not 1. When that happens, we're still going to find a product and sum, but this time we're going to find numbers who have a product of a times c. 2 times negative 4 is negative 8, and a sum of the b value, 7. The numbers that satisfy that product and sum are 8 and negative 1. Now what we do with those numbers is different than in our first example. We actually split the middle term into a sum of 8x and negative 1x. So I'll rewrite the original quadratic equation as 2x squared plus 8x minus 1x minus 4. Notice all that happened was we rewrote that positive 7x as 8x minus 1x. It's equivalent, but this will allow us to now factor this by grouping. If I look at the first two terms, if I take out a common factor, I would take out a 2x. And the last two terms, I could take out a common factor of negative 1. And now both of these terms have a common binomial of x plus 4, so that can be factored out. And once it's factored out, we're left with 2x minus 1 as the second factor. And the last thing I want to show you is a common trick that will show up, and it's if we have a difference of two perfect square values. If we have that, there's a rule. It's called the difference of squares rule. If you have an a squared minus a b squared, it factors to a minus b times a plus b. To help you see that this is a difference of squares, I'm going to rewrite the 9 as a 3 squared. So based on the difference of squares rule, I know this would factor to x minus 3 times x plus 3. There you go. Now you know how to factor quadratics. Must know number 6, you need to know how to solve quadratic equations using the method of factoring. So I'm going to give you two equations that we can solve by factoring. Let's look at the first equation. I want to figure out what value of x could I sub into that equation to make the left side equal to the right side. Since I want to know when this is equal to 0, I know if it was in factored form, it would be easy to find out what would make that product be 0. So I can get it into factored form first by removing a common factor of 2 from all of the terms. And now looking at the quadratic in brackets, I could factor it by finding numbers that multiply to c and add to b. The numbers that multiply to negative 12 and add to negative 1 are negative 4 and 3. So I could factor that quadratic that's in brackets into x minus 4 times x plus 3. And now using the zero product rule, I know that the product of those three factors is 0 if any of the three factors are 0. Well, x minus 4 would be 0 if x was 4, and x plus 3 would be 0 if x was negative 3. So there are two answers to that equation, 4 and negative 3. The second equation, notice that we're trying to figure out how can the left side equal 10. That's a little more difficult, so the first thing we'll do is take that 10 and move it over. You should always set your quadratic equal to 0 before solving. And now I'll solve this by factoring. Because the a value is not 1, I'll need to find numbers that have a product of a times c, so a product of negative 30, and a sum of the b value, 13. The numbers that work are 15 and negative 2. So I have to split this middle term into 15x minus 2x. And now I factor by grouping. I'll remove a common factor from the first two terms. I'll take out a 3x. And I'll take out a common factor from the last two terms. I'll take out a negative 2. I have a common binomial of x plus 5. I'll factor that out. And when I factor that out from both terms, I'm left with 3x minus 2 as my second factor. Now that it's in factored form, I know that product would be 0 if either the x plus 5 was 0 or if the 3x minus 2 was 0. X plus 5 would be 0 if x was negative 5, and 3x minus 2 would be 0 if x was 2 over 3. So once again, two answers to that quadratic. Now you know the basics of solving by factoring. Must know number 7, solving by completing the square. Let me give you another equation to solve. Now, not all quadratics can be solved by factoring. For example, there are no numbers that multiply to negative 8 and add to negative 6. So for that reason, we need a different method for solving this quadratic. If we convert this to vertex form by completing the square, we'll be able to easily rearrange to isolate x. So remember, to complete the square, we put the first two terms in brackets, and then we want to create a perfect square trinomial by, inside the brackets, adding and subtracting half of the middle term squared. Half of 6 is 3, and when we square it, we get 9. I'll get the negative 9 out of the brackets by multiplying it by the 1 that's in front. And then this quadratic's a perfect square trinomial, so it factors easily. The numbers that multiply to 9 and add to negative 6 are negative 3 and negative 3, so it factors to x minus 3 squared. And now we just rearrange this to isolate x. I'll start by moving the negative 17 to the other side, and then I'll move the squared to the other side by doing the inverse of squaring, which is plus or minus square rooting. So x minus 3 equals plus or minus the square root of 17. And then lastly, move this 3 to the other side. So I have x equals 3 plus or minus root 17. There are two answers there, 3 plus root 17 and 3 minus root 17. They're both irrational answers, so I'll leave it in exact form, just like this. You could use a calculator to get an approximate value for each of those answers if you wanted to. There you go. Now you know completing the square is not only a method for figuring out the vertex of a quadratic, but it can also find you the solutions to a quadratic equation. Must know number 8, solving using the quadratic formula. Now, if we had just a general standard form quadratic, and if you applied the method of solving by completing the square to that general quadratic, it would end up rearranging to be x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That's the quadratic formula, and it can find you the solutions to any quadratic equation. Let me show you an example. Let's actually use the quadratic equation that we had in the last example. We know the answers to this should be 3 plus or minus root 17, but we can avoid the whole process of solving by completing the square by just subbing into this quadratic formula the a, b, and c values of this quadratic that has been set equal to 0. Subbing into quadratic formula, it tells me to do the negative of the b value, so negative 6 is just 6, plus or minus the square root of the b value squared, so negative 6 squared, minus 4 times the a value times the c value. That's times 1 times negative 8. And that all needs to be divided by 2 times the a value of 1. If I simplify underneath the square root, I have 36 minus negative 32. That's 68. This radical can actually be simplified to the square root of 4 times the square root of 17. And I know the square root of 4 is just 2, so I'll rewrite it as just 2 root 17. And now in this fraction, the 6 is being divided by 2, and the 2 root 17 is being divided by 2. That means I could simplify this. 6 divided by 2 is 3, and 2 root 17 divided by 2 is just root 17. Notice those are the same two answers we got by solving by completing the square. This just avoids us having to do that whole process. Those are the exact answers. You could get the approximates just by typing on your calculator, 3 plus root 17 and 3 minus root 17. Now you know how quadratic formula works. Must know number 9. You have to know about the discriminant of a quadratic. The discriminant, if I show you quadratic formula, is the part underneath the square root, the b squared minus 4ac. Whatever you get underneath the square root in quadratic formula actually tells you a lot about the number of solutions or the type of solutions you're going to have to the quadratic. If b squared minus 4ac is bigger than 0, you will get 2 real solutions to the quadratic. Those 2 real solutions could be rational or irrational numbers. They will be rational if the b squared minus 4ac value is a perfect square number. But if b squared minus 4ac is not a perfect square value, you'll get irrational solutions. Another useful tip is that if b squared minus 4ac is a perfect square, that also indicates that the quadratic is factorable. But if b squared minus 4ac is not a perfect square, then you know the quadratic is not factorable. If b squared minus 4ac is equal to 0, you will only get one real solution to the quadratic equation. And that's because if underneath the square root is 0, the square root of 0 is 0, so you'd be adding and subtracting 0 from negative b. Adding and subtracting 0 gives you the same value, therefore only one solution. If b squared minus 4ac is negative, so if it's less than 0, there are no real solutions to the quadratic equation. There are complex solutions, but no real solutions. So what could all of these scenarios look like graphically for the quadratic? If a quadratic has two zeros, you would know that it intersects the x-axis twice. If it has 1 0, you know that its vertex must be right on the x-axis. And if it has no zeros, that means the vertex is above the x-axis and the parabola opens up, or it's below the x-axis and the quadratic opens down. And there you go. Now you know the usefulness of the discriminant of a quadratic. Must know number 10. You need to know a few different ways of finding the vertex of a parabola. Let's say we had the standard form quadratic y equals 2x squared minus 12x plus 10. If I wanted to find the vertex of that parabola, there's a few different ways we could do that. We could do completing the square. We could average the x-intercepts. Or a shortcut to that, we could do negative b over 2a. Let me show you all three of those. So remember, completing the square is a method of getting that into vertex form. First two terms in brackets. Common factor out the 2 that's in front of the x squared. Then add and subtract half of 6, which is 3, squared, which is 9. So add and subtract 9. Get the negative 9 out of the brackets by multiplying it by the 2 in front. And then lastly, factoring the quadratic in the brackets, it factors to x minus 3 squared. And outside the brackets, I have a negative 8. So the vertex is 3, negative 8. Let's see another way we could find that by first finding the x-intercepts of the quadratic. So I'll set y to 0. And let me common factor out a 2 while I'm at it. And now I'll try and factor this quadratic by finding numbers that multiply to 5 and add to negative 6. The numbers that satisfy that product and sum are negative 5 and negative 1. I know this product would be 0 if any of the factors are 0. X minus 5 could be 0 if x is 5, and x minus 1 could be 0 if x is 1. Now I know the vertex is going to be right in the middle of the x-intercepts. So the x-coordinate of the vertex, I just have to average 5 and 1. So add them and divide by 2, and I figure out the x-coordinate of the vertex is 3. And then to find the y-coordinate, I can just use the standard form equation of the parabola. Just replace each of the x's with 3, and you'll get a y-coordinate of negative 8. Or a shortcut to all of this, you can just use the a and the b value of the standard form quadratic to find the x-coordinate of the vertex. All you have to do is this formula here, negative b over 2a. So negative 12, which is 12, over 2 times the a value, so over 2 times 2. So I have 12 over 4, which is 3. And then once you have the x-coordinate, you can just calculate the y by subbing in the x into your equation, and you would get negative 8. So there you go, 3 different ways of finding the same vertex of that parabola. Hopefully these 10 must-knows made you feel more confident with quadratic relationships. Let me know what you want a top 10 of next. Jensen.